In this video, we'll review the basics of scientific notation. Scientific notation is a way to write very big or very small numbers in a little bit of a shorthand method. So it is a way to write very big numbers or very small numbers with less digits. So it's a shorthand way. In a shorthand way. Let me demonstrate what I mean by this. So here we have the distance between the Earth and Mercury is 36 million miles. So we have a lot of zeros to contend with. We want to express this in scientific notation. So in scientific notation, we have a number in the front that is between 1 and 10. So we would have a number right here that has to be between 1 and 10 times something with a base 10 to a certain power. So this would be our power up here. If it is a big number, greater than 0, this will be a positive power up high. And if it is a tiny number, then it would be a negative. So I'm going to put a decimal point here and I will count back until I get to a number between 1 and 10. So as I count, I will say 1, 2, 3, 4, notice that big step, 5, 6, 7. That would be the number between 1 and 10. So we have 3.6. So I'll place that here. And then we would say this is times 10 to the power of however many hops we had to make. So that would be 10 to the power of 7. So I could erase that and have it look a little cleaner, and we'll have 10 to the power of 7. So it's a different way to express a number with a lot of zeros or a very big decimal. Let's look at more examples. So a value written as the product of a number between 1 and 10 and a power of 10. So again, let's suppose we had 3.7 times 10 to the 4th. That would be a number written in scientific notation. And what you want to do is use that value to let you know how to change it back into a number. So if we were to use that value, we would say, well, we started with 3.7, and we'll look at this 4, and this 4 tells us the number will be a bigger number. It's going to grow, it's going to get larger, because this is a positive number. That means you move your decimal place that many spots to the right to make your number bigger. I like to leave those little spaces and then I fill them with zeros. So I now have 3.7 times 10 to the 4th is in scientific notation, but as a number, it's 37,000. If I were to have had 2.6 times 10 to the negative 3, I would look at that negative power and say that means it's a tinier number, so I'm going to move to the left. So I'll write my 2.6, and instead of moving the decimal point to the right, I'll move it to the left. 1, 2, 3, and I'll fill in those spots with zeros. So I would have 0.0026. So if we went from scientific notation to standard notation, the problem could say, please write this in standard notation. Let's take this problem for example. Let's say you have 4.675 times 10 to the 5th. And they say, write this in standard notation. You want to just think, they want me to turn this into a regular number. Think big number, because the power is positive. So you'll take your 4.675, and I'll write it down below again, 4.675, and I look at that 5 and say it's bigger than 0, and that means it's going to be a bigger number, so I move to the right 5 places. So I take where I start at the decimal point, and I move 1, 2, 3, 4, 5. So I'll fill those 2 spots in. I always like to take that last step of putting the zeros in, so I would have 4, 6, 7, 5, 0, 0, and then add some commas so I can read that as 467,500. If that were to be a negative 5, we would have moved it to the left. And then I will take a look at when we start in standard form and we want to go to scientific notation. So let's suppose we have this number. We'll make it another big number. So let's say we have, okay, so let's say we have 3,675,400 and we want this to be in scientific notation. So we identify to ourselves that it's a big number. If it's a big number, that means your power is going to be bigger than 0. So actually bigger than 1 because it needs to be between 1 and 10. And that means that you're going to put your decimal at the end and you'll count how many steps you need to go to get a number that is between 1 and 10. That's our rule for scientific notation. It must be that that first number is between 1 and 10. So I'll stop right here and I would have 3.675, and I typically can round to 2 decimal places. So I would look here and see that this is 5 or greater. So I could change this to 3.68 with rounding rules times, and since I'm using green, I'll change over to all green, times 10 to the, let's recount, 1, 2, 3, 4, 5, 6. So this would be 3.68 times 10 to the 6 in scientific notation. And that wraps up our introduction to scientific notation, or our quick review.